8. Composition and structure of atmosphere. Can a person live without air? We eat food 2 to 3 times a day and drink water more frequently but breathe every second. Air is essential to the survival of all organisms. Some organisms, like humans, may survive for some time without food and water, but can't survive even a few minutes without breathing air. That shows the reason why you should understand the atmosphere in greater detail. Atmosphere is a mixture of different gases and it envelopes the earth all round. It contains life-giving gases like oxygen for humans and animals and carbon dioxide for plants. The air is an integral part of the Earth's mass, and 99% of the total mass of the atmosphere is confined to the height of 32 kilometers from the Earth's surface. The air is colorless and odorless and can be felt only when it blows as wind. Composition of the atmosphere. The atmosphere is composed of gases, water vapor, and dust particles. The proportion of gases exchange in the higher layers of atmosphere in such a way that oxygen will almost be in negligible quantity at the height of 120 kilometers. Similarly, carbon dioxide and water vapor are found only up to 90 kilometers from the surface of the earth. Gases. Carbon dioxide is meteorologically a very important gas as it is transparent to the incoming solar radiation but opaque to the outgoing terrestrial radiation. It absorbs a part of terrestrial radiation and reflects back part of it towards the Earth's surface. It is largely responsible for the greenhouse effect. The volume of other gases is constant, but the volume of carbon dioxide has been rising in the past few decades, mainly because of the burning of fossil fuels. This has also increased the temperature of the air. Ozone is another important component of the atmosphere found between 10 and 50 kilometers above the Earth's surface and acts as a filter and absorbs the ultraviolet rays radiating from the sun and prevents them from reaching the surface of the Earth. Water vapor. Water vapor is also a variable gas in the atmosphere which decreases with altitude. In the warm and wet tropics, it may account for 4% of the air by volume, while in the dry and cold areas of desert and polar regions, it may be less than 1% of the air. Water vapor also decreases from the equator towards the poles. It also absorbs parts of the insolation from the sun and preserves the Earth's radiated heat. It thus acts like a blanket, allowing the Earth neither to become too cold nor too hot. Water vapor also contributes to the stability and instability of the air. Dust particles. Atmosphere has a sufficient capacity to keep small solid particles, which may originate from different sources and include sea salts, fine soil, smoke soot, ash, pollen, dust, and disintegrated particles of meteors. Dust particles are generally concentrated in lower layers of the atmosphere. Yet, conventional air currents may transport them to great heights. The higher concentration of dust particles is found in subtropical and temperate regions due to dry winds in comparison to equatorial and polar regions. Dust and salt particles act as a hygroscopic nuclei around which water condenses to form clouds. Structure of the atmosphere. The atmosphere consists of different layers with varying density and temperature. Density is highest near the surface of the Earth and decreases with increasing altitude. The column of atmosphere is divided into 5 different layers depending upon the temperature conditions. They are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere is the lowermost layer of the atmosphere. Its average height is 13 kilometers and extends roughly to a height of 8 kilometers near the poles and about 18 kilometers at the equator. Thickness at the troposphere is greatest at the equator because heat is transported to great heights by strong conventional currents. This layer contains dust particles and water vapor. All changes in climate and weather take place in this layer. The temperature in this layer decreases at the rate of 1 degree Celsius for every 165 meters of height. This is the most important layer for all biological activity. The zone separating the troposphere from stratosphere is known as tropopause. The air temperature at the tropopause is about minus 80 degrees Celsius over the equator and about minus 45 degrees Celsius over the poles. The temperature here is nearly constant, and hence it is called the tropopause. The stratosphere is found above the tropopause and extends up to the height of 50 kilometers. One important feature of stratosphere is that it contains the ozone layer. This layer absorbs ultraviolet radiation and shields life on the Earth from intense, harmful forms of energy. The mesosphere lies above the stratosphere, which extends up to a height of 80 kilometers. In this layer, once again, temperature starts decreasing with the increase in altitude and reaches up minus 100 degrees Celsius at the height of 80 kilometers. The upper limit of mesosphere is known as the mesopause. The ionosphere is located between 80 and 400 kilometers above the mesopause. It contains electrically charged particles known as ions, and hence it is known as ionosphere. Radio waves transmitted from the Earth are reflected back to the Earth by this layer. Temperature here starts increasing with height. The uppermost layer of the atmosphere above the thermosphere is known as exosphere. This is the highest layer, but very little is known about it. Whatever contents are there, they are extremely rarefied in this layer, and it gradually merges with the outer space. Although all layers of the atmosphere must be exercising influence on us, geographers are concerned with the first two layers of the atmosphere. Elements of weather and climate. The main elements of atmosphere which are subject to change and which influence human life on Earth are temperature, pressure, winds, humidity, clouds, and precipitation. These elements have been dealt in detail in chapter 9, 10, and 11. End of chapter 8.